Welcome back to Summarize Science. The center of our own Milky Way galaxy is a place of mystery, shrouded in dense dust and crowded with stars, making it incredibly difficult to study directly. But what if we could learn about its history without ever looking there? A new paper titled Chronology of Our Galaxy on the inner Milky Way stellar age distribution does just that, using a clever form of galactic archaeology. The researchers didn't point a telescope at the galactic core. Instead, they studied stars right here in our own solar neighborhood. They focused on a special type of star known as supermetal-rich stars. In astronomy, metals are any elements heavier than hydrogen and helium, and these stars are packed with them. Such high metal content suggests these stars couldn't have formed out here in the galactic suburbs. They must have been born in the dense, element-rich furnace of the inner galaxy and migrated outwards over billions of years. So, by studying the ages of these local migrant stars, we get a direct window into the history of the galactic center. And what they found is fascinating. Star formation in the inner Milky Way wasn't a smooth, continuous process. Instead, it happened in distinct, powerful bursts. The team identified major episodes of starbirth happening around 13.5, 10, 7, 4, and 2 billion years ago, with more recent activity as well. You can see these clusters of stars at specific ages right here in this plot from the paper. So, what could cause our galaxy to suddenly spring to life like this? The likely culprits are cosmic collisions. The researchers found that the timings of these starbursts, with one exception, line up perfectly with known mergers or close encounters with other, smaller galaxies. Events like the galaxy's collision with the Gaia-Enceladus-Sausage satellite about 10 billion years ago and repeated passes by the Sagittarius dwarf galaxy would have sent shockwaves through the Milky Way. These gravitational disturbances would have compressed huge clouds of gas, triggering massive waves of new star formation across the entire galaxy. But there's still a puzzle. The massive starburst that happened 4 billion years ago doesn't line up with any known major merger. This leaves an intriguing mystery for astronomers to solve. It could be a sign of a previously unknown galactic collision, or perhaps it was triggered by an internal process, like the final settling of the galaxy's central bar. So, to recap the main points. By studying migrant stars in our own backyard, scientists have uncovered a new history of the Milky Way's core. This history is not one of steady growth, but of violent, episodic bursts of star formation. These bursts were likely triggered by our galaxy colliding with and absorbing smaller satellite galaxies. This work gives us a powerful new tool to understand the evolution of our galactic home. It provides a fossil record of ancient cosmic violence and helps us build a more complete timeline of the Milky Way's dramatic past. Thanks for tuning in to Summarize Science.